Hi guys, this is 1-2 in Behavior and Extrema. It really isn't that tough. You just have to recognize what a graph is doing at the end, on the ends of it, and the extrema, high points, low points, that kind of thing. Okay, so objectives, identify in behavior, and whether a function is increasing or decreasing on an interval. Okay, so critical points are those points on a graph at which a line drawn tangent to the curve is horizontal or vertical. Okay, so that's what it means. That would be a critical point because when you draw a line through it, it is horizontal. That's a critical point. When you draw a line on it, it's horizontal. And that is one. When you draw a line on it, that's vertical. Okay. So, also have one going this way, but your critical point, again, would be vertical. Okay. This is a maximum. And since it doesn't go any higher than that on the graph, it's an absolute maximum. This is a minimum. Okay. And this is called a point of inflection, when it changes direction. Okay. All right. So what I said before, the absolute maximum, when it's the very, very lowest point, or the absolute minimum, when it's the very, very lowest point. This point right here is a low point on this curve. It's not, however, the absolute minimum. It is one called the relative minimum. Okay. Relative to the points around it, it is a minimum. Okay. So this particular graph has a relative minimum and an absolute minimum. You've only got an absolute maximum there. There is no absolute minimum because it's going on forever. And this one has no maximum because that's going on forever. It's just going to keep getting bigger and bigger forever. Okay, here you've got your relative minimum, your relative maximum. There is, in these cases, there's no absolute maximum or minimum. And that's because this is going to increase forever. X is just going to keep getting bigger and bigger and bigger forever. And X is going to keep getting bigger and bigger, getting smaller and smaller forever in this direction. When X is going to negative infinity down here, it's going to keep getting smaller and smaller. X is going to positive infinity here, it's going to keep getting larger and larger. Okay? So it's never going to change. All right. Locate the extrema for the graph. Name and classify them. Well, this right here, you're looking at this point. The -4 is the lowest point. That is the absolute minimum here. Okay. This is a relative minimum. Okay. And this is a relative maximum. There is no absolute maximum. You would also say here that at -3, you have a relative min, of -1. This would be at 1, you have a relative max of 5. Okay? So, and that's an absolute minimum of -4. When X equals 4. Okay? Like I said, it's going on forever and ever, so it's never going to get an absolute maximum. All right, this one tells you that you've got critical points, maximum, minimum, or a point of inflection. When you take one on either side of the thing and see what happens to it, if it is smaller than that point, then that means it's a maximum. If one is small, bigger and one is smaller, it's an inflection point. And if both of them are smaller than that, or larger than this point, it's a minimum. So it looks like this. You got negative 189 here, and then the negative 187 is up above it. So you can easily do this on Desmos. You do not need to do the algebraic anymore, but you definitely want to look at the graph and see what it's doing. Okay? When you graph this, determine the interval on which the function is increasing and the interval on which it's decreasing. Okay? It stops doing anything at this point right here. That is your absolute maximum. And it's the point right here of 5, 3. And you can count it out. 1, 2, 3, 4, 5. 1, 2, 3. That is your vertex of a quadratic equation. Okay? So, what you are going to say is, because you are coming up to this value right here at 5, as x goes from negative infinity to 5, it is increasing because it's getting bigger and bigger and bigger. When it's getting greater than 5, it is decreasing. Okay? So when x is less than 5, increasing. X is greater than 5, decreasing. Okay? At 5, it's not doing anything. It's just the maximum. Okay? So right here, once again, you have a vertex at negative 3, negative 5. This is the absolute minimum. Okay? For x is greater than negative 3, it's getting bigger. It's increasing. For x is less than negative 3, it is also increasing. Okay? So you've got a critical point. It's an absolute minimum. All right, so this one has more than one critical point. You can look at here. There is, because it's going on forever, no absolute maximum. Because it's going on forever here, there is no absolute minimum. This is a relative max. This is a relative min. Okay. At x equals negative 2, and at 1 it changes direction. So there you go. Okay. This is an increasing function, and that's what it's saying right here. The function is increasing when it's less than negative 2. Negative 2, 1, 2, 3, 4 and a half, it looks like. At negative 2, I know that, it's increasing. This is decreasing while it's between negative 2 and 1. And then it is increasing again when x is greater than 1. Okay? In behavior, this is what the graph does when x is going to infinity. It's getting larger and larger and larger, and x is getting smaller and smaller and smaller. Okay? So, here are the rules. If you have an even power, an x squared or an x to the 4th, your ends are going to point the same direction. If out front here, your a is positive, okay, it's going to point up. That's a being positive. A is greater than 0, positive. If a is negative, if a is negative, it's going to point down. Okay, that's called the end behaviors. If you have an odd power, x cubed, x to the 5th, anything like this, the ends point in the opposite direction. If the a is positive, you have the left side down and the right side up. If it's negative, This one's negative. You have the left side up and the right side down. Works the same way as if you had slope on a negative slope on a line, which makes sense because x is an odd power. Okay, and this is the same thing right here. So when you go back through your notes, you'll see if a is positive, the ends point up. If a is negative, the ends point down. Okay. This is explaining what I was telling you on this. This right here is a positive slope because you have y over y is positive over positive here going to negative over negative here, which makes it a positive slope or positive direction. If you've got this one, this is positive over negative or negative over positive. That's going to give you a negative slope. So that's why you have this one being the A is negative. Okay, so not too tough. All right, x is getting larger and larger is written this way. X is getting smaller and smaller is written this way. Y is getting larger and larger is written this way. And y is getting smaller and smaller is written this way. P of x, just like we had f of x last time, this just means the y value. What is the y value doing when the x value is doing this? Okay, so here you go. If you've got an even power, x squared, okay, here's how it's written. P of x is going to positive infinity. It's not going to stop. It's going forever as the x is getting bigger and bigger. And over here, that P of x is going to positive infinity as your x is getting smaller and smaller and smaller. This one, when your A is negative, when you got a negative out front, your P of x is going to negative infinity. It points down just like I said it did. And this one points down, whether x is going negative or x is going positive. So right here, we've got x cubed, and you've got an A out front, which is positive, just like I just finished telling you. You got positive over positive, makes that positive. Negative over negative makes that positive. So P of x is going to negative infinity as x is going to negative infinity. So every time you're looking at this for y is positive infinity. This for y is negative infinity. For x, this is positive infinity, and for x, this is negative infinity. So, in this case, as x is getting positive, larger and larger and larger, y is getting larger and larger and larger. As x is getting negative, going to negative infinity, y is going to positive infinity. As x is going to positive infinity, y is going to negative infinity. So it's not too tough as long as you know how to translate that. It looks really bad if you're just reading it, but it's not really bad if you just remember what we said on this earlier slides. If it's positive, they'll point up. If it's negative, they point down. And then you have to look at this and what it's talking about here. But it shouldn't be too tough for you. I think you'll do just fine. Good luck.